We're now going to count combinations, which is similar to counting permutations. So it's like permutations, but there's a big difference in that order doesn't matter. So it doesn't matter where you sit in the class, it just matters that you're sitting in the class. So how many combinations are there of some grouping of things or people so how many, if we have 25 students in class, but only 20 of them show up, how many different combinations are there of those 20 students in the classroom? And so the big key here is whenever you notice that order doesn't matter, then you have a combination. And the formula is C of n, comma, r is equal to n factorial over r factorial times n minus r factorial. And I want you to notice this is very much the same as our n choose r. These are the exact same formula, so this is just another way of writing our choose, but here it's specifically because we are counting combinations. So let's look at two examples. Suppose we want to find how many combinations there are if we have 9 total objects, and we are going to pick 2 of them. So this is 9 factorial over 2 factorial. If you remember from before, these two always have to add up to this one, so it's 7 factorial. And this is equal to 9 times 8 times 7 factorial over 2 times 7 factorial. The 7 factorials go away. 8 divided by 2 is 4. And so we end up with 36 combinations that we can pick 2 in any order of the 9 that are possibly there. The other one that we're going to show is the combinations of 7 total and 3, which is 7 factorial over 3 factorial times 4 factorial, which is 7 times 6 times 5 times 4. I stop at the bigger one. 3 times 2 times 4 factorial. And 3 times 2 is 6. So here we ended up with 35 total combinations of 7 objects of which we pull 3 out. There are 35 different ways we could pull those 3 out if the order doesn't matter. And so this is our key. This is how we get through these combinations. But again, the key is look to make sure that it says that you're counting combinations, or that what you're counting, the order doesn't matter.